We are moving into our next topic, which is going to connect to the exponential equations that we did before, but now we're looking at another way to work with exponents. So this is one of the first topics that is completely brand new in Algebra 2. And this is looking at something called a logarithm. Now, you may have a little bit of experience with logarithms in a science class. You actually see them show up a lot in a biology class. Logarithms are used to measure things like sound waves and decibels. It can be used to measure earthquake magnitude. So it is something that you may have a very, very little connection to in other courses. A logarithm is essentially another way to write something that is an exponential function. So we want to think of logarithms and exponential forms as going hand in hand. When we write a logarithm, when we kind of look at a logarithm, I often tell students to follow a cloud pattern. What I mean by that is when you look at a logarithm, this number here, the b, is referred to as the base. So that base is going to be taken to this power, and it doesn't like when I do that, and getting this answer. So we're going to say that the base b to the y power equals x. And when I first did this, someone had said, well, just draw a cloud, have you kind of a cloud going here. Always originate at the base to the y exponent equals x. So we can take anything in this form, this is called log form, and we can write it in its equivalent exponent form. So we're going to practice that a little bit, and I'm also going to show you how Delta Math does that. So at the top, you kind of see my two different forms. So I have a whole bunch of questions here in a list, and the directions are asked to rewrite it in exponent form. So all of these are logarithm forms. Everything you'll notice, we're going to go to exponent form. So you're going to do the base 2 to the 5th power equals 32. So the exponent form of that is 2 to the 5th power equals 32. The next one is 5 to the 0 power equals 1. So 5 to the 0 power equals 1. Then we're going to have 10 to the 1st power equals 10. Then we have 10 to the negative 1st power. When I take something to a negative power, it moves it to the denominator. 10 to the negative 1st power is 0.1 or 1/10. 2 to the negative 1 power is going to equal 2. Or 1/2. 1/2. When you're putting a fraction to a power, put the fraction in parentheses. So 1/2 to the negative 1 power equals 2. And then 16 to the 1/2 power equals 4. So 16 to the 1/2 power, you may remember, hopefully you remember, that the 1/2 power is the same as saying the square root. So 16 to the 1/2 power equals 4 should make sense because the square root of 16 is 4. So we can take anything in log form and write it in exponent form. We can also do it in reverse. We can take anything that's written as an exponent in exponential form, and we can write it in log form. For some reason, these take an extra second for me. I feel like the other ones are a little more natural. Your base number is going to be the base of your logarithm. So your base of your exponent is the base of your logarithm. This number is going to go next. I often call it the big number. It doesn't really have a name. And your answer, what's on the other side of the equal sign in a log, is always going to be the exponent. That's what your logarithm is actually finding. It's finding like a missing exponent. So we would say log base 3 of 81 equals 4. Next one, your base number is going to be the 1/2. Your big number is going to be the 8. And a logarithm will always equal the exponent. Next one, we're going to have a log. Your base number is 64 because that's the base number of the exponent. Your big number is 1/3. And I put it backwards. 1 second. Base number is 64. Your big number is 4. And your answer is your exponent, which is 1/3. 1/3 power is the same as cube rooting. So what's that saying is the cube root of 64 is 4. And then the last one, your log, your base number is 2. Your big number is 32. And your answer in a logarithm is always the exponent. So let me show you what Delta Math is going to do. So on Delta Math, you are going to have to convert log equations to exponential equations. And I'm going to start with pretty simple ones. I'm going to start with ones that have a whole number base. So something like this. They're going to look really messy, but they're actually pretty easy to type in and to write in. So we're going to follow that same pattern. So we're going to say base 3 to the 3rd power equals. that whole big thing in parentheses. So when you type it on your keyboard, I'm going to open up my keyboard to make this easier to type in so you can see it a little quicker. So when you type it on your keyboard, you're going to type 3. You're going to hit the exponent button to the third, and that's going to equal all of that stuff that's in parentheses. And if you want to keep it in parentheses, you can. At this point, since it's the only thing on that side, you can just type it in as is and submit it. Let me show you another one. So this one, your base number is 4. Your exponent, kind of follow the cloud, is going to be 5x. And it is equal to 5x plus 2. See if I see any others that might be a little tricky. This one's what we just did. I think it should be pretty good. Getting a lot of similar ones here. Yep, you're just going to follow the cloud. So 9 to the third power equals this value. All right, going back. We have a couple really basic rules, and then we're going to talk about some special logarithms. So with our basic rules, we have a rule that says that no matter what the base is, log base b of 1, you always get 0. And the reason is because any number to the 0 power equals 1. So if I asked you, what's the log base 53 of 1? It's going to be 0, because anytime you're taking the log of 1, no matter what the base is, you get 0. We also have a property that says if our base number and our big number is the same, we're going to get 1. So if I have a log base 5 of 5, we're going to get 1, because any number to the first power is going to equal itself. We can also use that to do some canceling. So if we have a variable here, if we have a log base b of b to the x, you're just going to get that power. Same thing here. If we have a base b of b, we're going to get canceling, and we're just going to get that power. The idea is exponents and logarithms are inverses, meaning they cancel each other out. They kind of undo each other. So when you have a log of a base and then an exponent with the same base, those will cancel. There are 2 special logs. They are buttons on your calculator. The 2 special logs are called common log and natural log. Common log is any log that is base 10. You will actually not see the 10 written. So if you just have something like this, it is understood to be a 10 there. This is a button on your calculator. Give a second to load up. So you've seen this button before. The button on your calculator is the one that just says log. It's in the very first column, halfway down. It actually says log on it. If you hit that button, it will type in just log, and then you can take any number that you want and plug it in there. It is called common log because it is used, so it's such a common one to use. It's used a lot in like science applications. So that is your common log. Anytime you do not see a number there, it is an understood 10. The second special type of natural log, and some of you might have seen this on your calculator as well, is called natural log. Your natural log is written as an L and an N next to it. The reason is it actually has European roots. I think it was developed it was in Scotland. There was mathematicians that work with that. And any language that is like a Spanish or French, any language like that, instead of saying natural log, they would say log natural. That's why the L comes before the N. Random history there. And natural log is any log that has base E. We talked about E being the natural base. Well, then that's going to be the base of the natural log. So when we see this, it is understood to be an E. It actually won't be written there. So you won't see it written like this with the base E. Instead, you'll see this LN notation. The button on your calculator, you've actually hit it many times, but you used it to do the E, is the one that actually has an L and an N on it. And that's what it'll pop up on your screen. And you can type in the natural log of some number, and it will give you an answer. You get a lot of decimals for these. So on Delta Math, there's going to be some that you're going to have to rewrite with a common log. So let me show you this. So here's a common log 1. The reason you know it's common log is there's no base number written. So that means that we understand it to be a 10. So when I rewrite it, I'm going to do 10 to that power equals that value. So when I type it in my answer, I'm going to type in 10 to the power of x plus 2 equals, and then this whole big x squared plus 5x plus 5x x minus 18. So you will have common log ones, and you will need to know that the base is understood to be a 10. You'll also have natural log ones, so they'll look like this. You'll notice there's nothing written there. We understand that the base is e, so we're going to type in e as our base, and then the power is going to be 3/7, and that's going to equal 4x plus 1. So if it is a natural log, we understand the base to be e. If it is a common log, we understand the base to be 10. So you will see a little bit of everything. You'll see common, you'll see natural. So that, going back to our notes, that's the basics of logarithm. We're going to get into how you evaluate them in a second, but those are the basics of how they work and some of the special ones that you will see.